Ladies and gentlemen, please welcome Senior Vice President and General Manager of Networking and Security, Martin Casado.
Thank you. Hello, voice check. Thank you so much. All right, thank you. So I'm Martin, and I'm going to be talking about network virtualization. I've roughly broken this talk up into three pieces. So for those of you that have seen me speak before, the first third is going to be some background and summary. You've probably heard it before, but please just indulge me because I want to bring up those that haven't heard me speak, haven't heard about this up to speed. But I also kind of wanted to develop a common language. Then I'm going to talk about kind of where we've come, like where things are as far as adoption and how we view the evolving use case. A little bit of a spoiler, the use case has evolved to be more as much about security as anything now, so I want to really do a deep dive on the last third to focus on that. Okay, blah, blah, blah. All right, so let me kind of provide a bit of a background. So where did network virtualization come from? How should you think about it? There's a lot of confusion out there. You hear all of the acronyms. Few of us even know what they mean. I sure don't. So I want to give you a very simple mental model for network virtualization. And it's the following. If you look at the traditional way to build a data center, especially in the network, we take a lot of functionality and we put it in the networking hardware. Right? So the networking devices themselves do a lot of functionality. Things like fault isolation. Things like security, things like QoS, things like billings have traditionally been part of the networking devices themselves, which is fine. It's a reasonable way to build a data center, but it is somewhat of a traditional model where you've got human beings interacting with physical gear. And so if you look at implementing new security policy, a person takes that and brings it to the physical device. Fault isolation, service chaining, whatever it is, this is very kind of manual thing. You guys have heard this all before. It's nothing new. What's fun is to contrast this with Generation 3 data centers, which are typically characterized by kind of the web giants guys, the Googles, Facebooks, Amazons, et cetera, that you hear about. But don't think about a scale thing. Think about more a Generation 3 data center. So if you look at a modern data center with a Generation 3 app, it looks actually very, very different. So functionality that has traditionally been in the network has actually been re-implemented in software. So instead of things like security being in the physical network, or service chaining, or discovery, or load balancer, or whatever, it's been re-implemented as part of software. Does that make sense? And then the physical network itself becomes very, very simple, generally just involved in packet forwarding, right? It's very common for a modern data center, a modern Gen 3 data center, to just have an L3 ECMP fabric. That's it. L3 ECMP, you're running OSPF. Convergence times are very quick. Load balancing is done very quickly. And then the things that we normally put in the physical network is re-implemented as part of the application. Why? Well, for a number of reasons. One, applications have much deeper semantics, right? Like you know what you're doing in the application because you're the application, right? So if you're doing load balancing, you do a much smarter version of load balancing. Or if you're doing security, you can do security over things you know about. Also, like a software model is a nice model, right? Like the CLI traditionally has been like an HCI, like a user interface experience, not like an API experience. And so if you're re-implementing things in software, you've got like software controls, software operations, you've got objects that you can wrap software around. And of course, innovation speeds just tend to be faster if you're implementing things in software, right? I mean, an ASIC design cycle is 2 to 4 years. A software design cycle is 3 to 6 months. And so if you look at a modern data center and you do like a vertical cross-section, you're like, OK, how awesome is this? It's awesome on a number of vectors, right? So CapEx tends to be quite a bit lower. I've heard quotes, a third to a fifth. Just cheaper. It's cheaper because you haven't tied features to a hardware rev cycle or a hardware design cycle. Right? So now the only thing the hardware has to do is pass packets, software does the rest. And again, I'm not talking about what I'm doing, I'm not talking about network virtualization, I'm talking about data centers that have evolved over the last 10 years that run the most effective, most cost-effective, most operationally effective operations and businesses on the planet. So these are by far the most scalable data centers ever. They run the most successful businesses, and we don't have to argue from first principles about whether these are good or not. They've just demonstrated to be awesome. CapEx, OpEx, and innovation speeds. So the problem is, and kind of the dirty little secret is most people can't have a data center like this because they don't control the application. The only way you can build a data center like this is you control the application and you rewrite these functions as part of the application. But if you own IT and you've got 7,000 applications that are running there and they require all of these network services because these protocol stacks have existed for 20 years, this type of data center doesn't work. You can't use an L3 fabric if your application requires L2 adjacency, right? You can't run just an L3 fabric with no ACLs if you don't, you can't do basic segmentation and isolation in your application. So you can't have this in normal IT environments, right? So awesome from OpEx, CapEx, run the most successful data centers on the planet, inaccessible to most of IT. So that's where network virtualization came from. And the basic idea of network virtualization is, can we paint a software layer on the servers that provides the benefits of a modern Gen 3 data center, but doesn't require a change to tools, to operators, or to applications? So I want to step through that very quickly, but I just want you guys to have a mental model of where this came from. Remember, Darwin, over the last 10 years, the most sophisticated data center builders on the planet, Darwin has spoken and said the best way to do this is you move software to the applications. Nobody sold them this architecture. This wasn't part of a sales motion. These are people that build awesome data centers. And you can look at them, you're like, wow, on most metrics they're better. So how do we get everybody else to this model? OK, what is VMware NSX? It's an embodiment of our network virtualization solution. I just want to give you, given that as background, kind of a basic idea of how it works. I know many of you know this, just please indulge me. You have a data center. Your data center has physical switches. In the case of NSX, as long as they pass IP packets, they'll work. So your physical switching infrastructure can be anything. It can be Cisco. It can be Arista. It can be L3. It can be L2. It can be IP over InfiniBand, whatever. As long as it has IP connectivity, the physical network will be compatible with NSX. Now, to be very clear, that doesn't mean that all physical infrastructures are the same. I mean, clearly one that is oversubscribed isn't great, or clearly one that will arbitrarily drop packets isn't great, right? So no virtualization is going to overcome physical limitations, right? There are better physical networks and there are worse physical networks, but generally that you look at them and you say, listen, like things like over-provisioning, unified latency, unified jitter, the ability to fully utilize the fabric, these are the things you look at when building a physical network, and like a basic L3 network normally fits the bill. Connected to physical network, you have these servers. And on servers, in most virtualized environments, you have a hypervisor. In the hypervisor, you have a vSwitch. Now, vSwitches have been in the hypervisor forever, right? So if you are a VMware customer and you run ESX, VMware has been touching every one of your packets in software already since you've deployed it. Every single packet. It comes out of the guest. It's in software in the hypervisor, which handles the DMA to the NICs, right? So every one of your packets has already been handled in software for a very long time. And now the idea is can you use that position of software that's already handling your packets in software and build a network abstraction so that you can provide all networking functionality in software as opposed to offloading it to the hardware? So what NSX does is it kind of controls all of these vSwitches and creates what you can think of as a network hypervisor. So here's the analog to ESX. What is ESX? ESX is I have a computer, I paint it with some software, and then I now have a virtualized abstraction of that computer that I can dynamically create, shrink, move, clone, snapshot, whatever. So I've changed the concept of a server from like this physical entity to a logical entity, and now that it's a logical entity, I can orchestrate it with a program and I can treat it like soft state and like the world changes, right? So I want to do the exact same thing with a network. So I'm going to paint it with this thin software layer on the edge, and then instead of creating physical networks, I'll give you a virtual network. Now, virtual network looks like physical networks. On service model, on operational interfaces, they support L2 and L3. They support all of the counters, the standard management interfaces. You can RSpan them. You can ERSpan them. I mean, they look like physical networks, so you don't have to change your tools, and you don't have to change your applications, right? They support all the service model that you need, but they have the operational model of a VM, meaning you can create them dynamically and grow them and shrink them and move them around. And they're decoupled from hardware, right? So from this thin software layer, you create these notion of virtual networks. And so now when I spin up like 5 VMs for an application, instead of taking those 5 VMs and like attaching them to a piece of hardware, and then if they move, having to reconfigure that hardware and be limited by that hardware, I'm attaching it to a virtual abstraction that can be programmatically controlled that has the operational model of a VM. And so from your perspective, virtual networks should be just like physical networks in function from L2 through L7, from operations and management, from visibility, except for have the operational model of a VM, just like compute virtualization. Okay, so where are we now? So it's kind of funny. Like I feel like I've been up in front of many of you guys for a long time, for years. I mean, I've been doing this now, gosh, going on 9 years, and I've been in exactly this, and I always say the same thing, which is like, next year is the year of network virtualization. Like whenever you have early technology, you always have like this magic beans type pitch, right? Where you're like, oh, I've got these magic beans, and you take them and you plant them, you get a beanstalk, and they'll grow up, and there's going to be gold at the end, and this really evangelical engagement, and it's always been just about to happen in next year. So I'm really happy. Like this is kind of, I think, one of the first times, very honestly, we can stand and be like, you know what? Like it's arrived. Unequivocally, it's arrived. And there are a number of indicators of why things like SDN and network virtualization have arisen, and I can't go through all of them, but I just want to talk to that. So if you look just at customer traction, not only are we seeing kind of this asymptotic adoption, which is great. I think we've announced over 150 paying customers. But it goes across all verticals, right? It isn't like we totally dominated go-to-market of one niche. Like we're the experts in selling to the Fed space, and so now you don't know whether the technology is being adopted or I'm just really good at selling into the Fed space, right? So if you look at, we're seeing adoption in telcos, service provider, financials, beverage companies, manufacturing, airline companies. I mean, it's across most verticals, and this is it's a key indication of maturation of markets. Not only this, and this is a little bit anecdotal, is when you introduce new technologies into markets, they're really hard to sell because people don't know how to think about them, right? So the only way you can sell them is you have these very specialized sales teams that are like stone cold killers, and they understand how to have the discussion, and you go ahead and you send them in the account. It takes a long time. There's a lot of dinners, and you're working on selling it, and you're convincing the customer after time that they understand it, and it's this really engaged sales cycle. Right? It's not led by the account manager. It's not the guy with like the white teeth and like the 42 long suit that has the boat. Like that's never the guy that sells early technology. It's the technologist that knows how to have the discussion. I mean, that's how you do early sales, right? Because they're the only ones that can have the discussion. It's very technical. And that's been the last 5 years. But what we're seeing more and more is we're actually seeing, and I'll give you an anecdote, we're actually seeing sales where there was just an account manager, there was no SE, and actually it was the customer that was driving the discussion. I mean, we had a couple of accounts that came in from Asia that I had no hand in. I wasn't part of the customer sales. And actually, I went to the account manager that sold NSX in these accounts, and he had no idea what NSX was, right? So clearly, we've entered this point where the customers are being educated, and they're being educated for a number of reasons. They're being educated because most of the major vendors have agreed that network virtualization is the right way to think about it. We may disagree on how you implement it, but most people are like, yeah, you should have a network virtualization layer. You should have an abstraction. You should have it API driven. So there's a lot of marketing dollars going into this. There is convergence at an architectural level, at a high level, and so now it's just about kind of product and fulfillment. So it's exciting. It's very exciting to me to see that, yeah, we're actually seeing adoption. I mean, we announced, what, $100 million run rate business for network virtualization. I mean, this is a real business, right? And what's even cooler about that from a technology standpoint is like, I think now, we've done all of this work, for the last 7 years, and you always kind of predict how people are going to use technology. But things like virtualization are always like these kind of general like widget platforms that you can apply to different problems. And so what we predict people use it may not be how they use it. And now that we have a lot of production deployments and a lot of adoption, and we've seen the sales cycle, we can actually step back and reflect on kind of what are the drivers, why people bought it, what problems they're applying it to, and what problems they're going to apply it to in the future. So I want to talk a little bit about that, and I want to then focus on one of the more emerging use cases. So I think if you really step back and you kind of go at the appropriate zoom level and you look at the market, I think there's 3 reasons why people adopt network virtualization. So the original one was speed. And I know speed is an overloaded term, but I mean, it really comes down to all of the early customers wanted to reduce the provisioning time of networking to 0. So if they ran a business where like network provisioning got in the way between them and getting money, whether that's innovation or onboarding a new employee or onboarding a customer, network virtualization can reduce that time to 0, then there's some value, right? And so, I mean, these were early service providers, a lot of test dev environments, things like IT application environments, so to deploy new applications and so forth. So all the new ones, all of this discussions were around agility and speed to get to some business objective, and that's still probably 40 to 50% of, I would say, the deployments. Initially, I always thought that economics was going to be a big driver, right? Because I thought I'd go in and be like, hey, listen, I can save you $100 million a data center. And I was really surprised early on that absolutely never, I don't think that was one cell was on economics in the early days. And I stepped back and well, why is that the case? Like if I can go in there and like Nicira, which is the company that I ran that got acquired by VMware, I remember one customer, I was like, wow, for this data center, I think I can save you $100 million. That would have funded my company twice. That's a lot of money. And so they're like, But the reality is for early technologies, companies don't know how to evaluate risk at all, right? So they go, oh, that's great, you saved me $100 million, but if my network doesn't work, I go out of business, so it doesn't help me, right? And so in early technology cycles, cost and economics aren't a major part of the selling motion. They come up in discussions when you're talking about things like pricing, but not for the initial sell. Now that is starting to change as we're seeing a lot of production deployments, right? So now people can evaluate the risk because there are customers running this or running this at scale. You have a number of production deployments. So more and more, we're actually seeing this become part of the dialogue, which is, I want an OpEx saving or I want a CapEx savings or whatever it is. It's actually becoming more of the dialogue. And so that's definitely a big use case. But the biggest one is actually security. And it's a total surprise to me that security is as popular as it is. But I would say this is by far the largest use case. It's probably driving 40 to 50% of our sales. And it was not obvious to me at all when we were creating the technology that this would be the case. And so I'm actually going to spend the last half of my talk just on security. So I don't want to get too far ahead of myself. I'll actually describe the use case and the value later on, but I want to tee that up a bit. So let me just kind of bring the talk up to where I am now. I gave you guys the background on kind of the technical background and the rationale behind it, which is trying to move functionality into software to kind of mimic these large data centers. Then I talked about where we are on the adoption cycle, which first time we can be like, yeah, it's actually being adopted and it's a real business. And now I'm focusing on the use cases, kind of the emerging one that's really interesting is security. And it's driving a lot of business. And so let's spend some time looking at that. OK, so for those of you that don't know, that I actually come from a security background. I actually, my first job out of college was doing computational physics. I actually worked in the weapons program. This is in 2000. And then and 9/11 hit. And actually, it's like the focus of the government changed right at 9/11 from being this anachronism of the Cold War that actually cared about nuclear weapons to actually something a lot more relevant like intelligence. And so a lot of there's a lot of shifts in focus away from these old programs to new programs. And I was part of that shift, and I moved from working on weapons to working with the intelligence community. And I did that for years, and I loved it. It was cool. I did a lot of kind of hacky security stuff, and it was a lot of fun. But security was a total mess. And in fact, that experience was the background for all of the work I did later on in SDN when I was at Stanford, which actually became SDN and OpenFlow and then led to Nicira. That was kind of very formative for me. What's even more interesting is so I spent all this time in security. I leave, I do this diversion of networking for 10 years, and I come back to security and wow, almost nothing has changed. So I'm going to kind of give you a relevant macro level perspective of what I mean by that. So I think this graph sums it up, which is security is actually pretty depressing. And so if you look at industry trends, the amount of dollars that we spend on security is outpacing the amount that we spend on IT. Right? So this is clearly something of growing importance. But from an industry-wide perspective, the only thing that seems to be outpacing the amount we spend on security dollars is the amount of money we lose on security breaches. Right? So it's we're fighting this losing battle. And you look back, you're well, why is this the case, right? It's not that we're not spending. It's not that we don't have this awesome innovation incubation engine of new companies. It's not like we don't have smart people. It's not like we don't have good technologies. If we can't spend our way out of it and we can't throw people at the problem, what is the fundamental problem here? And I actually think that a lot of the problem is architectural. And so in an effort to kind of give you guys a flavor for the nature of the problem and the depth of the problem, I actually want to step back and walk through an actual kill chain of how a common attacker will break into a data center. And this is driven from like real break-ins, from real data. We've talked to a number of companies that have been broken into, and we've kind of canonicalized this into a generic kill chain, but it is representative. And it's interesting, we actually were talking with one of the intelligence communities recently, and we were kind of going through the kill chain, and they're like, oh yeah, we had one recently that mapped that pretty closely. So this is not like some kind of exercise in trying to make you scared, right? This is actually kind of what we can derive from real kill chains here. And so the reason I'm doing this, I just want to give you guys an appreciation of the nature of the problem, then kind of where we throw money at the problem, and then how things like network virtualization can help it and why this is driving the sales. Okay, so that's why I'm doing this. All right, let me go through the kill chain. Okay, so here's a modern attack, right? So here are the steps that an attacker will do to break into, and I'm assuming the attacker is highly motivated. It doesn't have to be a nation state actor. It could be like somebody that just wants to make a lot of money, but highly motivated to go after a large company, right? There's real dollars at stake. This isn't about me like changing your web page to kind of like promote all my homies, right? This is like a real, this is like a real attack, right? So the first thing that happens is human recon. Thank you, Facebook. Thank you, LinkedIn. I mean, this is not a very difficult thing to do. You can reverse engineer the social infrastructure of an organization very easily. Actually, I've got this really relevant anecdote, which is my birthday was June 29th. On my birthday, I got an email from my sister with a picture wishing me happy birthday and having a link to a birthday card that was a phishing attack. Guaranteed that came from Facebook. You know, guaranteed that information came from Facebook. But like, listen, I've been in security for a while. I mean, just looked. Hey, I know my sister probably would forget my birthday, so like I was a little suspicious. But like, I was a little concerned here, and clearly it was a phishing attack, right? And like when people do human recon, they're not trying to reproduce exactly the org structure. They don't want to know like who's the CEO because everybody knows that. They want to know who's the CEO's admin, right? I mean, these are the types of information that you want to pull out. So let's say, so now I've done this, I've done all this mapping, I've put together this org chart, the social org chart, which is much more important than like the business org chart. Like, who do you trust, who do you talk with, who do you hang out with, who's in your book circle type thing, right? Then there's the next attack vector, R&D. You know, when nation state actors, we build our own a lot of the time, so that takes a lot of effort and a lot of time. But you know, you have products like Zeus today, which will kind of generate exploits for you, and will give you 24-hour, 365-day-a-year support for like 9K, right? And so you can actually buy 0 days, you can buy exploits, you can create your own, and you will come up with a primary attack vector to break in. So all of this happens without having any idea of the company that this is happening, right? This is all happening, you know, behind doors somewhere, either me buying exploits from somebody, me buying Zeus that's going to help me create exploits, or me developing my own exploits. Okay, then there's the initial compromise. So the initial compromise is, you know, like that first foothold into the company. There's tons of ways this happen, right? So I think the most important thing for you to take away is like, if I want to get code on your server, I will somehow. Whether I'm like buying somebody off, sending in the guy with a black mask to break through the window, to put something on. I'm doing some remote network hack thing. I do some sort of a supply chain attack. Actually, one of the big security companies that got attacked recently, it was a supply chain attack where they were able to get on one of the contractors' laptops, bring into this data center. Phishing, water holing, there's a lot of ways that you can get on. And it's actually fairly easy, I can tell you from experience, to get some piece of code beyond the perimeter. Right? I mean, for intelligence agencies, this is an economic exercise, right? I mean, like what, 20K in most countries, and I can get a pice of code somewhere, right? I don't even have to worry about anything that would raise my profile. So you have to assume that over a period of time, some code is going to break into your perimeter and get installed in the server. So what happens then normally? So today, strain A gets placed beyond the perimeter, strain B gets placed beyond the perimeter, strain A wakes up, establishes command and control with the attacker, who's a live human being somewhere, and now the attack starts. So you've got two strains that are sitting in the data center, one that's, you know, happily asleep, one that's awake, and one that's awake is starting to figure out what's going on within the infrastructure. And so now this game happens where, you know, try and escalate privilege as much as you want, so you get access to as many things as you want. You start scanning, you look around, you know, you're doing kind of lateral movement, you're breaking into different things, you're wiping logs, whatever you can, you're trying to do it as quietly as possible. This is strain A that's doing this, and all the time you're talking back to the attacker, right? So let's say, you know, land on some Linux box, I don't know, use some local vulnerability, ptrace vulnerability. I've got root privileges now. And now from there, I start scanning and monitoring and branching out. And so this happens for a while. At some point, the malware is probably going to trip something, detect something. So some guy's like, wow, this machine seems to be talking when it shouldn't be, or I thought I turned it off, or this application is on here. Somehow it's going to be identified. If it's identified, you know, the company will remove strain A. Of course, the attacker has seen all of this. Strain B wakes up. Strain C comes down. They plant strain C, and it continues. Most of the attacks we look like have this kind of dual strain. Well, it starts out as dual strain, but multi-strain model where there's a very long interaction that's going with the attacker. And once things get found out and you scrub it, then another one pops up and the information is gained, and then you continue the attack. All right, so 10 is kind of the most difficult thing to do, which is at some point you've got the virus and it's in a lot of places. The attacker knows a ton about the infrastructure. Now it's time to break into the data stores. Which is like, I mean, you're not breaking this, you know, attackers aren't breaking into this stuff for their own health. They normally want something. That something is almost always data, whether it's credit card information or PII or whatever it is. And so at some point you'll get to the data stores, and you know, if it's encrypted, whether it's brute force, whether it's finding the key, whatever it is, they'll break in. And they always do after a period of time. It could be slow, it could take months, but they'll break in. Once they do, that data is chunked up, it's parceled up, it's normally stegged into images. You can steg it into JPEGs and post it on Facebook for all I care. And you'll exfiltrate this information over time. You know, normally look like legitimate traffic, normally on a shared public website, you know, whether it's Gmail or Facebook, and then you clean everything up. Often, the extent of attack is only understood once the FBI comes in and contacts the organization. Right? So the organization, oh, we took care of this malware, we're done. And then, you know, 2 months later, the FBI comes, hey, listen, you know, we think that you've been compromised. Okay, so I just wanted to walk you through that to give you guys a sense of the nature of the attack. What I'm going to do now is I'm going to kind of zoom out to kind of give you a more macro picture here. Okay. There you go. Okay, so a few things. First off, it's really important to realize that a common attack is highly targeted. There's a lot of money at stake. It's very interactive. It's not like I write my worm and I send it out there and I sit back and drink my Mountain Dew. I mean, this is kind of like, this is a very interactive process. It's incredibly stealthy. And I think like gone are the days of like the 16-year-old in his boxers, right, with the pizza box, right? I mean, these days, there are large organizations that have a lot of information both before they go in and while they are part of the penetration. But if you look at industrial efforts, like as an industry, if you say, okay, so how does the industry deal with this threat? It turns out that we've got a very, very limited view. Like the technologies have a very limited view of security and a very myopic strategy for dealing with them. So basically, 80% of our dollars are basically on the perimeter. And all they're trying to do is stop, all they're trying to do is stop the attacks from coming into the data center, the stuff on the left side, and they have nothing to do with the stuff on the right side. 80% of dollars today are on the perimeter, which means that it's only for stuff that's going in and out of the data center, which is almost none of the attack, right? Like I will get beyond the, listen, if I am a focused adversary, I will get beyond your perimeter. I will. I promise I will. Like, I will masquerade as an employee. I mean, I will get in somehow. I will buy somebody off, or I'll do something network. And once that happens, the majority of the attack is happening where there's almost no visibility and control. There are very, very few controls within the data center. I'm gonna talk to why that the case is. But there's very few security controls within the data center. And those that are there are generally pretty ineffective, actually. And so assuming that, you know, I can always get code on your server somehow, you know, it's very difficult to detect attacks. Okay, so now I want to talk about microsegmentation as a use case with NSX. So in what follows, I'm going to talk about like how you can use network virtualization to address this problem, the security problem, both controls within the data center, but also a set of ancillary problems on kind of context and isolation that are involved. So the rest of this is going to be a little bit technical, but I think we actually have a video here that's going to tee it up. So the video, this is marketing, it's high level. I'm going to go ahead and talk to more of the details in a second.
Hi again, it's Raj. Since Adam and I started taking a software-defined data center approach, we've gotten a lot of attention around here. Virtualizing the network has completely changed the way we operate. The executive staff is impressed, and the word's getting out. Yesterday, the guy who runs our security team, Jesse, had lunch with Adam, and they tossed around a few ideas. He had a few questions of his own and popped by my office. He said that even though we have a strong data center perimeter defense, it's not infallible. He still has nightmares about threats that do make it through. Those threats sneak through the perimeter defense riding on legitimate user access. And once inside, there are few controls to keep them from moving laterally from server to server. Basically, he doesn't want to be the guy that has to explain the how and why to the shareholders when we get compromised. Jesse has always imagined applying microsegmentation inside the perimeter, but has never seen a way to realistically operationalize, keeping up with all the firewall changes, with VMs being created, moved, and deleted all the time. He wanted to know if our software-defined data center could make a zero-trust security approach possible. So I told him to take a seat. Check this out. It's not like how you traditionally manage firewalls. This is different. It's very automated and baked into the software-defined data center. Here, for example, we can provision a web tier workload or a database tier workload with PCI data, and the appropriate controls are enforced. If the VM moves, its policies move with it. And if we delete the VM, its policy is deleted. And if we identify a vulnerability, the attributes of the VM are dynamically updated and quarantine controls are enforced. I can see his wheels are spinning. He says, that all sounds great, but the volume of east-west traffic is massive. How can this be done in software? What's the gag? I tell him that from a performance standpoint, it's a whole new ballgame. The firewalling is baked into the NSX platform. It operates in the kernel of every hypervisor. You get 20 gigabits per second of throughput per host, my friend, and that's only applied to the VMs running on that hypervisor alone. We have over 100 hypervisors. You do the math. So Jesse's like, okay, I get it. Virtual networks are isolated by default. And what you're talking about here is basic stateful firewalling for multi-tier app environments, right? But what about this? What if we want to apply more advanced next-generation firewalling capabilities for some critical application types? I remind him that NSX is a platform, not a competing firewall product. Look, Palo Alto Networks and a bunch of other partners have already integrated with NSX to take advantage of its distributed enforcement and automated provisioning. I think that's when things clicked. Jesse's face lit up. Really? Where have you been all my life? Wow, I mean, you just saved us a pile of money in firewalls alone. So how fast can we get this deployed? I tell him, hey, it's software. How about this afternoon?
All right. Okay, so actually beyond like the marketing polish, there's actually some core technical points here that I want to focus on. All right, so let's start about attack surface. So if I pop up in a traditional, even virtualized environment, if I spin up a VM in a data center, what's the attack surface? Well, let's assume that the application is compromised. So I mean, the hypervisor, the almost 10 million lines of OS on the top of rack switch, and any shared services, AD, LDAP, DHCP, DNS, any shared firewalls, L4 through 7 services. So in any of these, if I attack them, I win, right? Like if I smack AD, you're done. If I smack your routing infrastructure, you're really done, right? All of this is trusted computing base that is attack surface. And we created networking technologies for hyperconnectivity, right? I mean, we created networking technologies for organic growth for the internet. That's what IP was based for, right? Everybody can come and join. Everybody can talk to everybody. Unfortunately, the corollary to that is like every psychopath is your next door neighbor. And we don't have core technologies to limit this stuff. Now, if you do things like microsegmentation, in theory, is I pop up VMs, I attach them to a virtual network, and then they scan, and everything now is outside of the attack surface except for the hypervisor. If you compromise the hypervisor, now you've gotten outside of the magic box. But if you don't compromise the hypervisor, you've got a limited attack surface. So like the physical infrastructure, not in the attack surface. Shared services, you can give independent versions of shared services, so you can actually reduce the attack aperture. You can reduce the attack scope. So the question is, like, why hasn't it been implemented before? It's not a difficult concept. And the reality is it's just really hard. I mean, if you look at the problem of enforcing like the north-south border, like let's say you have a data center. Like putting things like segmentation and controls in a meaningful way on the north-south border is actually not that hard. I mean, what is the most you have to do from a capacity perspective? The most? 100 gigs? That's honestly 2 servers. That's it. You have 2 servers. You don't have a lot of state distribution. You don't have a lot of state sharing. You can use 2 servers to put real controls on the north-south border. So what if you're trying to put sophisticated controls to limit this attack surface within the data center? I mean, one top-of-rack switch is what, half a terabit? I mean, you have 48 ports of 10 gigs. So that'd be like, what, 5 servers for top-of-rack switch? You have hundreds of top-of-rack switch. I mean, you've got now thousands of appliances and all the people to manage it, and you still don't actually have distributed state consistency. Like, these weren't built to be distributed. So typically, we didn't have the products that you could put for infrastructure security in the data center. They just don't exist. I mean, there's just too much data to deal with. Of course, you could say, well, I could put this in the application with application controls, but then you have this kind of arms race, which is I'm putting my controls in the attack surface of the application. If I put a security control in the application and that's what gets attacked, it isn't all that effective, right? And this is why, I mean, we have an industry where 80% of our dollars, 80% of our security dollars only touches about 20% of the traffic. This is reality. It's a grim reality, but it's the reality. So the idea of microsegmentations is really simple. The fact is with network virtualization, you solve this distribution problem. That's the goal. The goal is to run a little bit of software on all of the servers, and you distribute networking functionality, whether that's L2 or L3 or stateful firewalling or IDS or whatever it is. And so now every packet that goes in and out of a VM, you can apply security controls, and you still have global context and global coordination. And now you actually can have global things within the data center. So just to make a little bit of a comparison here, I mean, on the traditional model, you're going to see a packet leave a VM. The packet that leaves the VM, the only way that you can actually drop it is it goes to the perimeter. That's only about 20% of your traffic. But if instead you push the firewalling to the hypervisor, clearly you've got local enforcement. But as important, you actually have also all of the operations of virtualization, where now I've got an abstraction that's topology independent where I put my security policy. So I have created a virtual network, a virtual firewall, I put all my security policy in there, and as things come and grow and shrink and move around, that security policy is consistent. And moreover, I only update that when VMs exist, right? There's no way that you're going to update your, well, maybe you do, which is part of the problem. But like if you have an appliance-based firewall, you don't really know what endpoints are turned on or where they are. And so you've got basically the Cartesian explosion of all of your security policy. Where here, because it's tied to a logical construct, this is all managed from the same thing. So you'll only have whatever ACLs are relevant to the policy at hand. So it's all managed by the system. And for every packet going out of every VM, whether it's internal or external, you can apply a security policy to it. Okay, so now I want to talk a little bit about futures, because I think the first step in the security journey and the one that's driving the majority of the sales now is just microsegmentation. And it's very simple. You walk in and be like, listen, guys, you have a data center, you spend a ton of money, and it's applied to a minority of your traffic, and the most important traffic that in the data center where all your sensitive data is and all your sensitive application, there's very little control. Let's go ahead and fix this in a way that's capitally and operationally feasible. That's the microsegmentation pitch. But I think now, if we look into the future, there's a lot more that we can do to change the industry. And so I want to spend the last 10 minutes talking about that, and then I'll open it up to Q&A. Okay, so let me look a bit into the future. So I think one of the coolest things about network virtualization and the opportunity we have is, like, for the first time, infrastructure is getting married with compute in like this basic way that, like, we're talking about like network functions that are like running on x86 that are co-resident in RAM with the applications. And so you have a level of proximity and visibility that you've just never had. I mean, like, so much of networking has been guessing what's going on in the application, right? And guessing poorly, right? We're like, oh, it's an IP address. It must be an independent user. Yeah, right. It's a port number. It must be an application. Yeah, right. I mean, like, we've never done a good job of knowing what's going on at the edge because we've never been there. But now we're actually running network functionality there, and with VMware, we actually have the hypervisor so we can peer in and we can actually gain great insights. And I think this covers a lot of the industry that you can impact, whether it's performance, but certainly from security. So I want to talk a little bit about this notion of the Goldilocks zone that we've been talking about. So what is the Goldilocks zone? It's a term. It was probably a It's kind of a strange term to adopt, but it's what planetary scientists call the perfect distance away from the sun that a planet can be to sustain life. So it's not too hot and it's not too cold, it's kind of just right. And so the argument is the hypervisor is kind of a Goldilocks zone for security, which is it's close enough to the application to actually get context, things like users and data and what applications are running, but it's far enough away to actually have meaningful isolation. That's the idea. It's close enough for context, but far enough away for isolation so you can actually put security there. So to kind of tee this up, traditionally we make a trade-off between context and isolation, right? So if you put security controls in the application, you get tons of context. You know users, you know applications, you know what's intended to happen. I mean, it's not guesswork, you're at the right layer. It's semantically meaningful. You're at the right layer. But the problem is you're in the attack surface. Right? So if I put this great security control, if that application gets attacked, I can't trust it anymore. So you've got high context, but you have almost no isolation. Another place that we like to put security controls is in the infrastructure, which has the exact opposite problem, which is like if I'm putting ACLs in a top-of-rack switch, say, like I know almost nothing, right? I mean, IP addresses don't really tell me much. Ports don't really tell me much. Protocols don't tell me much. I can do protocol parsing with next generation firewalls, but that's actually fairly limited as well. So, I mean, there's value there. There's definitely value, but I mean, you know, like I can't see all the accesses or all the users. I mean, there's very well known limitations, but I'm pretty well isolated. So if you smack my application and you got some code there, I mean, in order to break into the router is still a big hurdle, right? I mean, the only attack surface is going to be like a communication stack or a management interface, right? So you're still fairly isolated. So you've got good isolation, but no context. So the question is can we somehow, because we sit between these 2 points, can we somehow provide both context and isolation? Because if we do, that would actually touch most verticals in security in a very significant way. And it's not just firewalling. It's network access control, it's intrusion prevention, it's threat analysis, it's all sorts of stuff. So this is what we've done, is we've been working on, and this is still futures kind of R&D stuff, but we have some pretty interesting proof points, is we've actually built into ESX the ability to establish a root of trust in the guest operating system. So I can, so you pop up the guest operating system, I can load a driver which establishes a root of trust, that's trusted code now, that I can pull out context, and we established a trusted path between that and the hypervisor. So I can pass that information down to the infrastructure. So that's what it is. So Goldilocks is some fancy term. All it means is there's code in the hypervisor which will establish a root of trust. So I've got trusted code running that's attested both on disk and like when it's running dynamically in memory, and it establishes a trusted path. So now I can pass information down for enforcement in the infrastructure. And the idea is to open this up to anybody to use so that now we can pull meaningful information out of the application or out of the OS, whether it's users, whether it's objects, whether it's files, whether it's actual application data, and make that available to infrastructure security technologies. Does that make sense? And by the way, like, I mean, this is fairly new stuff. I mean, there's a lot of like ESX hacking that goes on to get this stuff done. This is fairly new stuff, and it took a while to figure out how to do it without like using core encryption and making it fast enough. But this is something we've actually been able to achieve. And so, just a kind of some capstone comments on this before I end is that this isn't just about making a next generation firewall better because you can do firewalling on something like users, right? I mean, let me give an example of vulnerability assessment. So general vulnerability management works as follows. I've got a box that I put in my network, and then it scans remotely. And it normally does, like, it'll initiate a connection with the application, and a banner will come back, and it'll, like, regex that banner and pull out, like, something and be like, oh, I know this is a vulnerable version of something, therefore I'm going to issue a trouble ticket, right? I mean, that's what vulnerability management is. It's a remote box that will go ahead and it'll talk to something, it'll just look at a banner often. I mean, it does some sort of fingerprinting, which is fine, but listen, if I've compromised something, I'm going to make the banner look non-vulnerable, right? And so, I mean, I think it's good for what it's done today. I think it's a limited approach. But imagine if instead you ran your vulnerability management within the hypervisor and I just gave you access to the files themselves. Or hell, the process that's running in memory, right? Like, don't grep a banner. Look at the actual process in memory to see if this is compromised or non-compromised with this code you want. And if you think that this is vulnerable because you're looking at the process in memory, don't issue a trouble ticket, remediate it immediately because you're in the hypervisor, you're on the control path, right? You're no longer just a box that's sitting out far away. You're actually sitting there. You can actually do something about it. Make sense? So this is deep, deep context that you're giving something that's traditionally been basically a remote thing. Deep context, like anything you want, you can look at. I'll skip malware protection. It's pretty obvious. But like even like network access control is an obvious thing that you can do. You can be like, listen, I'm gonna run within the hypervisor some malware detection, and if it detects malware, it's gonna go feed into my network access policy. So I will dynamically quarantine things, and I'll dynamically bring them back when they're remediated. Again, now my security policy of what is on the network and what isn't, it's not. It's on this VLAN, or if you're really sophisticated, it is this AD group. It's something really dynamic, like McAfee tells me there's malware here. I mean, that's real deep dynamic context that's actually using to drive network access policy. So network connectivity is being affected by this kind of deep understanding of the network. So next generation firewalls, network protection, vulnerability management, IDS, all of these things I think come into play. And to be very clear, our goal is to build out a platform, which we will certainly use for our own products, but we want the rest of the industry to use as well. Okay, so that was it. I just want to recap very quickly, talk 3 parts about the background and where things are. And the reason I spent so much time on security, because it really is becoming like a very major focus. It's driving about 50% of our sales now. And so microsegmentation is the primary use case, but Goldilocks is an area we're going to be focusing on going forward. So now I'm going to go ahead and open up to questions in the last 15 minutes, if there are any questions.
Hey, Martin.
Hey, Niels. What's going on?
Hi. Quick question. Can you share with us some thoughts on containers and policies and how that'll affect microsegmentation with containers coming small?
Yeah, that's actually a really interesting question. So, no, it's a super good question. So NSX and technologies like it are perfectly compatible with containers, right? I mean, for us, we're like, it's some sort of an endpoint that I can attach a virtual port to, and so it can actually become part of the. It's very easy for NSX to be adapted with containers. In fact, we've actually had customers use it with containers, traditional Linux namespace containers for a long time. Right? And so there's certainly compatibility from a technology perspective. From a policy model perspective, there's no big change either. The interesting change is with the container, the isolation arguments change. Right? So if you're using traditional virtualization, like you actually have a separate trust domain, a totally separate trust domain. Especially with Linux namespaces, if I compromise the OS and like remote exploits in the OS are pretty pervasive, you're done. You don't have any isolation. So I think that the biggest thing when it comes to microsegmentation and containers to realize that now your attack surface is basically the system call interface and all of the drivers in Linux, which is enormous. Enormous, right? And so I think you need to have some additional protection if you actually care about enforcing this. Does that make sense? Like the security isolation for containers that story is incredibly weak because it's basically saying it's the entire OS, which has been exploited forever. And so I think that the long-term industry solution is either to use real virtualization or to introduce a horizontal security layer that runs in a different trust zone that only does security. Thanks. Any other questions?
Yeah, is there any worry that Goldilocks zone connection between the hypervisor and the actual VM is going to become the new focus of attack?
Yeah, I actually think that so you need to have some communication with a hypervisor anyways, and so I think things like the Goldilocks efforts will kind of address those issues, which are probably not focused on now. But I'm not Pollyannic. Like, I totally don't believe in perfect security. I feel that we just kind of move the security problem around for sure, right? And like we're just moving it somewhere else. It's like if you got things to secure, you want to know kind of where to put the guy with the gun or put the lock. And so right now, I think where you put the guy with the gun is on the hypervisor. I think all of these things use trust consolidation in the hypervisor as the security thing. So I think the attack surface becomes the hypervisor. So there's a couple things you can say about that. One of them is you can be like, well, now you really need to secure the hypervisor because we put a lot of eggs in that basket. But what's interesting with network virtualization is it's actually, from the perspective of the physical network, it's pretty normalized. It's actually pretty normalized. Like, it's an overlay, the traffic looks a certain way. And so now you have to secure every layer, right? You have to secure physically, you have to secure the virtual networking layer, you have to secure the application layer. So now you're saying, okay, what is my physical security? Now you're basically using ACLs to enforce the overlay. You're basically saying, if someone compromises, say I broke into the hypervisor and I've got unfettered access, now the job of the physical network is to ensure that the only communication can happen is exactly what's needed for network virtualization, which is actually fairly normalized compared to like, you can say anything to anybody. So I think it actually, yes, the focus is going to be to attack the hypervisor for sure. I think we will see more hypervisor compromises, but I think this posture allows us to have a much more sane multi-layer security approach so we can put things like ACLs in the physical network that are meaningful. Yo.
Sort of dovetailing on that question, I heard for the longest time that this is about overhead, for CPU overhead that NSX may require, that it's close to 0%. Can you talk a little bit more about that and share some thoughts?
Yeah, I mean, these questions are always kind of a little difficult. I mean, there's just so many variables. So let me just kind of give you guys a high-level mental model on performance. So the first thing is, anytime an application sends, a packet, a lot is going on, right? Let's talk about it. Let's say, like there's some high-level language Java that's talking to some high-level sockets library that's trapping into some high-level virtual machine that's talking to libc, which is then doing some trap to system call, which goes to the guest operating system. And so you've got buffering and copies all the way down, and now you're in the guest operating system, and you've got all the timer and retransmission segmentation that's going on. And then that traps, and that goes into the hypervisor. There's a domain crossing. You lose your TLB, by the way, when you do that. And then you've got all sorts of other stuff. You've got a vSwitch that you have today handling, and then the packet pops out. I mean, there's a lot of stuff that goes on in software today every time you send a packet. If you look at what a lot of the overhead is, a lot of it's just memory management. Seriously, it's memory management, especially when it comes to the domain crossings. I mean, like losing your TLB is like not a small thing, and like all the buffer copies are not a small thing. And so if you want to improve the packet performance for get network functionality, what you do is you want to reduce the number of interrupts, which is why TSO is so important. So TSO is TCP segmentation offloading. So you're basically saying, if I'm in the guest operating system and I want to send a packet, I better send a really large packet down to the NIC, DMA it, get it down to the NIC, and then the NIC can go ahead and segment it and send it off at MTU size frames. So now I'm only taking about 1/10 of the interrupts. That's how you get packets really fast out of a VM, right? So, and if I'm sending small packets, there's a lot of overhead because you're doing the changes. So now when you introduce things like network virtualization, like it's kind of noise compared to all of the other stuff that's going on, unless you come up with these canonically degenerate cases, which is you've got a packet that's going through all of these things and all these domain crossings. And so you normally are adding about like 8 additional hash lookups, which compared to like all the memory handling is noise, unless you're not being able to distribute it. Or distribute that load well. So there's not a lot of overhead in the networking functionality relative to this. Like the big ones are whether you can do TSO or not. So the big problems with encapsulation were, if I throw an encapsulation header that the NIC doesn't understand, I can't get TSO, therefore my performance sucks. That's where you go from 10 gigs down to 2 gigs. I mean, today we can tunnel at 10 gigs, right? I mean, we can tunnel at line rates. And so I don't think there's a huge concern for outbound sending traffic unless you're trying to do tons of ACLs or some real complex functionality. There are concerns for live lock issues on packets coming in, which is basically often if you're under a flood attack, like you get an interrupt in, you've already lost the game. And so there are some efforts to push QoS controls into the network, but otherwise there should be a noticeable difference in performance in most cases for the hypervisor alone. Now, when you're talking about like offloading to physical infrastructure, it's an own set of issues. That's why people are doing top of rack and hardware integration. But for the hypervisor itself, I mean, these are pretty well understood, and like the network virtualization is not the problem. Yeah. She's asking if we're using NSX in our primary data center and using SRM. So we use NSX in a lot of data centers. I actually don't know if we use SRM. Yeah, so that's the idea. For using NSX with SRM is you maintain the actual posture. Yeah, I mean, for a typical HA setting, that's absolutely the idea. Is like you maintain all of the network configuration when things fail over. Mm-hmm.
So in order to maintain these security policies and firewalls
Yeah.
per VM, what kind of management interface?
So the question is to maintain, these policies and high-level things, what sort of management interface you use. Again, this is like a fairly complicated question, so I'm a big fan of horizontalization and clean interfaces and APIs. And so, there are multiple layers of this system. The network virtualization layer, the northbound API to that is a provisioning interface and virtual network abstraction. So I can be like, create virtual network, create firewall, and there is no management or anything. That's a layer. There are multiple consumers of that layer, right? So on top of a basic virtualization layer, you normally have a management layer, and then on top of that, you have a policy layer. So there are multiple consumers for ours, right? So whether it's VCAC, it's vCenter, it's OpenStack, or it's our own policy system. We have one called Service Composer. That's a high-level policy system that consumes it, or a third-party one. I'm working on a project in OpenStack called Congress, which is a policy layer which will consume this as well. So I think like the big takeaway from you is this is a horizontal approach with an API. There's many consumers. For a total VMware stack, it'll be VCAC and Service Composer. But you can have any number of policy systems and management systems built on it. Good question. Yeah. Are there any constraints of using this feature with SRIV? You mean NSX? Yeah, you don't. So SRIOV, in my opinion, is de-virtualizing something. And so if you de-virtualize it, then unless you reproduce all of the functionality in hardware, there's no point in talking about virtualization because it's fundamentally at odds, right? So SRIOV is basically say, to heck with virtualization, I'm going to DMA directly into the guest and back. So I'm going to expose the physical address space to the network. So you're basically saying you don't want virtualization. So unless you reproduce all of this functionality in the NIC, which people have failed to do for about 10 years, then it doesn't make any sense. However, if virtualization higher up, for example, in the guest, there may be a use case that makes sense. But NSX won't work natively with SRIOV, unless it supports VTEP or something like that in hardware, but that ecosystem doesn't exist. It's a good question, though. Yeah, hi.
So as we think about applying NSX to other hypervisors, what would you say are your two biggest challenges to making other hypervisors be just as secure as ESX?
Yeah.
Or another way to answer it is, what tips would you give the other hypervisor vendors on how to step up and manage?
That's a good question. I mean, I think that this question reduces down to just basically securing other hypervisors. And it isn't specific to NSX. So NSX, the security posture we take is trust consolidation in the hypervisor. So we reduce the security problem to protecting the hypervisor. And like our pedigree, from Nicira, and we focused on KVM and Xen server environments. We've got a lot of experience in those types of environments. They come up with all the basic. Basic problems that are known for Linux and Linux security, which some are good and some are bad depending on it. And so I think that question just reduces to the how do you secure the hypervisor question. What is interesting is from the question that Niels asked, which is what about containers? Like I actually think hypervisor is a pretty good security model. Just be sure that you understand what you're doing and be sure not to put all of your eggs in one basket. Continue every security at every layer. But when you're going to containers, you're actually losing a trust domain. That makes sense? It's actually a different security posture. And so I think that from the industry should do one of two things. It should say, go ahead and use containers, they're awesome, but use containers and a hypervisor. Or we need to create a new technology, which is basically a separate trust domain for security controls. Right? So instead of installing a hypervisor, let's call it a security visor. And you install that, and it sits below the container, and it actually will establish the root of trust and do the enforcement. Because when you do containers, you're actually changing your security model. And that's kind of something where I think we need to be very careful with. Thanks for the question. Time for one more question. Anybody? Yep. What's that? The question is, what are our competitors doing? In Nicira, it was, when we were like an independent company, like everybody was our competitor, and we go out and we're competing with everybody. We're competing with Cisco and VMware, and everybody was our competitor, and like everything was hand-to-hand combat with the account, and it was like hard and a hard sales cycle. But we're actually, as part of VMware, we're in this very unique solution where, listen, we already have 500,000 customers. We already touch every one of their packets and software. We're the only company with native integration to ESX. I mean, like, listen, if I want like the vSphere to change, I walk down the hall. And so we're very much the incumbent. So I actually see no competitive limitation in the field at all, zero, right? We're totally limited with our ability to like support and develop things, right? I mean, it's not like, the reason like we're having friction in the field is because there's some hand-to-hand combat, right? I'm talking to a virtual admin. I'm like, listen, I already handle every one of your packets and software. Let me solve some of your networking problems too. So like the biggest like limitations I think in the field are things like education, organizational issues, basic support, scaling issues, and that, right? What is interesting about a macro from a competitive standpoint is you're seeing kind of a whole array of solutions being created under different verticals, right? Cisco's got something which is fairly hardware-centric, as you'd expect them to have. The big cloud guys are like, forget hardware and software. It's all just as a service, which has its limitations people know. And so I don't think that there's actually a network virtualization battle. I think the press kind of created one, and some of our competitors created one. I don't believe that exists. I believe there's a battle for IT. So the real battle is this. Do you want your data center or your IT to be kind of driven by converged infrastructure and hardware? Do you want it to be driven by software, or do you want to be as a service? That's the high-level dialogue, and I think we all know the players and all know that dialogue. And so often people talk about like the competition at the network virtualization stack. I don't really see it in the field, and I don't think that's the macro-level discussion. I really don't. It's a great question, though. All right, guys, I think I ran out of time, so thank you so much for your time and your patience. I appreciate it.